Dear students, in last classes we have completed large sample test chapter, and also we have taken a test on it, and based on your performance and the way or manner in which you have written the test and hypothesis and how you have highlighted the answers, so I am discussing on that part today. So there is a lot of mistakes you made in answers. So if you make the same mistakes, if you repeat the same mistakes in annual exam, you will lose marks there. So first what? So when you read the problem, identify the values given there. So what is mu, what is x bar, and what is whether standard deviation given is belongs to population or sample. Okay, so x bar will be given along with the samples. The mean of 40 samples is something. So 40 samples, that 40 samples indicates n here, and mean of 40 samples is suppose 25. Then 25 is the x bar. The mean weight of 100 students is 49 kg. So 49 kg is x bar and 100 is n. So why it is x bar? Because by checking the weights of 100 samples, 100 students, the weight is average weight is measured here. So 49 is a x bar and 100 students are number of samples n. And along with that, in the question they will be asked, can it be assumed the mean weight of students is 50 kg? Or can we assume that the mean weight of students is less than 50 kg? Or can it be assumed that mean weight of students is more than 50 kg? So in this manner the question will be asked, and the mean in this question is nothing but mu, the population mean, assumed mean. It is a or estimated mean. So based on certain assumptions, certain previous experience, it may be taken 50 kg is the average weight. Okay, so x bar is equal to 49 and n is equal to 100, mu is equal to 50, and standard deviation, it may be taken from the sample or maybe from the population. So from the population, how standard deviation is taken? So again, it may be based on the previous experience. Maybe our institution is conducting classes from last 10 years, and from last 10 years experience, based on the student weight they measured and calculated, then they may come to a conclusion that the standard deviation will be this much based on the previous year calculations. Always it may be similar, so they assumed. So this year also the average weight and the standard deviation of weight is this much. So if standard deviation is estimated, then it is denoted as a sigma, because it is a parameter, it belongs to population. If standard deviation is given based on the samples, the mean and standard deviation of 100 students, the average weight and standard deviation of 100 students is 49 and 5. Then 49 is the mean and 5 is the sample based standard deviation. So standard deviation belongs to those 100 students whose weight is measured here. Then it is denoted as S is equal to, and a little modification in the formula. So our usual formula is Z is equal to x bar minus mu divided by sigma by root n. So if standard deviation of population is given, use standard deviation here. If not, Z is equal to x bar minus mu divided by S by root n. So this will be our formula. Okay, so here, and when you write null hypothesis always assumes that population mean or population standard deviation or maybe population proportion or population's variance will be this much. Accurately it will tell it is this much only. So here what we can write H0 here, the mean weight of students is 50 kg. So symbolically mu is equal to 50. And don't write directly mu is equal to 50. Write it and show it in sentence. So the mean weight of students is 50 kg. Then show it symbolically. Then H1. H1 always we cannot say that it is not equal to 50 kg. H1 depends on the question. So if question is asked that, can we assume that the mean weight of the students is 50 kg? If you assume mean is 50 kg, then opposite to it is not equal to 50 kg. It may be more than that. It may not be more than. When we assume something, if it differs either side, either left side or right side, or it may be more or it may be less, then it is, we say, if it is not equal to 50 kg, then it is alternative hypothesis, opposite to the term. Okay, so question, if can we assume that the mean weight of the student is 50 kg, means alternative hypothesis will be the mean weight of students is not 50 kg. Symbolically, mean mu is not equal to 50. First alternative. Okay, it is assumed as 50 kg, then it is not 50 kg is the alternative hypothesis. Then what kind of question may be asked here? So another question may be asked here that, can we assume that the mean weight of students is less than 50 kg? So then also the H0 will remain same. The mean weight of students is 50 kg, and alternative hypothesis, that will be H1 is the mean weight of students is less than 50 kg. Symbolically, mu is less than 50. Then we call it as a left tail, lower tail, and we take a negative k value, that is critical value. So it may be asked for 5% level of significance, or maybe 1% level of significance. So depending on what level they have given, we take table value. So then in the diagram, where you can make mistake here also, when here it is a less than symbol, always left side or lower side or towards minus infinity. And here we show k is equal to minus 1.65 or 2.58. So whatever may be the value that we show here when it is less than. And when we write this hypothesis, then the diagram will be like this. Both this side we show minus k plus k. So 1%, 1.96, 5%, 2.58. Again, here 1%, 2.33, or 5%, 1.65. So like that here, one side we show. So I will mention here itself minus k. And the third alternative, only 3 alternative we get, not more than 3. Okay, and if the question is like that, can we assume that the mean weight of the students is more than 50 kg? Okay, so then H1, the mean weight of students is more than 50 kg, then mu is greater than 50. Then our diagram, So critical value, so greater than means towards right tail or upper tail. So here we mark the critical value at 1% or 5%, 1.65 or 2.33, whatever may be, we show towards right. So this is the diagram showing writing alternative hypothesis, and this diagram, these are must. You must show the answer whether it lies in the critical region or it lies in the acceptance region. So what is critical region here? So beyond this, towards infinity from this point, critical value towards infinity. So this is critical region. Here in a two-tail test, both the side we mark critical region, and in between this portion is acceptance region. And whereas in less than, that is left tail test, so this area negative infinity, towards negative infinity after k point, that is a critical region or rejection region, and this entire area up to towards positive infinity, it is acceptance region. And in upper tail or right tail test, so from k value, from this point towards positive infinity, this is critical region, and this area up to negative infinity, it is acceptance region. Wherever the answer lies in this area, it is accepted. If it lies beyond this line, then null hypothesis is rejected, because that is the critical region or rejection region. And before going to this diagram, first you must write the, after calculation with the formula, after calculating the problem, that is test statistic. So you must write at what percentage of they are given. It may be 1% or 5%. Level of significance. If it is two tail, then the critical values are. If it is one tail, then the critical value is. So show that what is the critical value, what is the table value. It may be 1.65 or 2.33 for one tail, and 1.96 and 2.58 for the two tail test. Then you will show where it lies in the diagram, whether it lies in the negative, in the acceptance region or in the rejection region. Then right here, since Z calculation lies in the either acceptance region or rejection region, where it lies exactly, then or symbolically whether Z calculation is less than positive critical value, and if it is greater than negative critical value. Then, so when if it is less than positive critical value and more than negative critical value, then it is accepted. If it is two tail, if it lies in between these 2 points, if it is more than upper limit, more than negative critical value and less than positive critical value, it is accepted. And here, if it is greater than negative k value, that is negative critical value, then it is accepted. And here, if it is less than positive critical value, it is accepted. So write that H0 is accepted or H0 is rejected. Then conclusion. So if H0 is accepted, write the same conclusion. What you have written here. The mean weight of the students is 50 kg. If H0 is rejected, then mention the mean weight of students is not 50 kg, or the mean weight of the student is less than 50 kg, or the mean weight of students is more than 50 kg based on what you have written in H1. So this is how we have to interpret for a single population. It is the same procedure for even proportion also. So instead of mu here, the proportion we write here. The proportion of students is, passing proportion of the students is this much. So proportion we write, whether it is equal, that is H naught. If it is not equal, or if it is less than, or if it is more than. So for the proportion and mean, the same procedure is followed.